We are back at AP Review. This is 2016 AB Free Response 4. So we are asked to consider the differential equation dy dx equals y squared over x, the quantity x minus 1. So part A, on the axes provided, sketch a slope field at the for the given differential equation at the 6 points indicated. So we're only giving these 6 points, and again, I did a pretty terrible job of drawing them, but you get the idea. So how much work you show on a slope field is entirely up to you, right? If you are a person who feels like you need to actually list all 6 points and find the slope and then have it in front of you, that's great. If you can just do it in your head, also great. You're not going to get any credit for the work that you show on a slope field. You're only getting credit for the actual slope field. So the 6 points indicated are 0, 0, right? 0, 1, 0, 2, right? 2, 0, 2, 1, 2, 2. And the slope is y squared on top of the quantity x minus 1. So when I plug in these values, right, so when I plug in y is 0, so basically both of these points, I'm going to get a 0 on top of a non-zero number, so I'm going to get 0. So at both 0, 0, sorry, that didn't show up well, and also at 2, 0, right, just if you're skipping ahead, you're going to get a 0 on top of 1, which is 0. Both of these should have horizontal slopes, right? So those are flat slope, or horizontal lines, slope of 0. So when I plug in 0, 1, right, I'm going to get a 1 on top of a negative 1, which is a slope of negative 1. So that means that at this point, 0, 1, I should go down 1, right 1, which is a slope of negative 1, right? When I plug in a 2, I'm going to get a 4 on top of that negative 1, so I get a negative 4, which means go down 1, 2, 3, 4, right 1. So that's going to be pretty steep negative, right? When I plug in 2, 1, I'm going to get a 1 over 1, which is a positive 1. So that's either up 1, right 1, or you could have gone down 1, left 1, right? So basically it's the counterpart to this, but with the opposite sign, right? And when I plug in 2, 2, I'm going to get a 4 on top of a 1, and so that'll be a positive 4, so it'll essentially be the same as this slope, but in the positive direction. So again, that's either up 4, right 1, or you could go down 4, 1, 2, 3, 4, left 1, which would be aiming for that same spot. So again, same counterpart. So that's your slope, right? When you're getting points for these in general, you usually get 1 point for the 0 or vertical, for the 0 slopes or the undefined slopes, right, if there are any, total, and then you get 1 point for the more typical slopes, like the numerical slopes. So again, these two were worth 1 point, and then the other 4 collectively were worth 1 point. So 1 point here, 1 point here. Cool. Part B. Oh, and before we move forward, another thing to note, this is a separable differential equation, right? You would be able, because the x's and y's are being multiplied or divided, you'd be able to split that apart. So that's definitely what you're going to be asked to do somewhere in this problem. And that's going to be the part of this problem that's worth most of the points, usually 5 to 6 points, depending on the AP. So slope fields, probably 2 points. They do not ask you to sketch any sample curves, so that's it. Part B, let y equals f of x be the particular solution to this diffeq with the initial condition f of 2 equals 3. Write an equation for the tangent line of the graph y equals f of x at x equals 2, and use your equation to approximate f of 2.1. Okay, so we're asked to find the equation of a tangent line first, right? So when we go to find the equation of a tangent line, right, anytime you're asked to do something that involves finding the equation of a line, right? So anytime you're asked to do the equation of a line, it's always going to involve 2 parts. Part 1, you need a point. Well, they just gave me the point. They told me that f of 2 was 3. So 2, 3, right? And then you're going to need a slope. And then you're going to put your answer, that's not how you spell slope, then you're going to put your answer in point slope. So my slope in this case is going to be dy dx evaluated at that 2, 3. So if I plug in dy dx evaluated at that 2, 3, I'm going to get a 9 on top of a 1, so I'm going to get a slope of 9, right? So what that means is the equation of the tangent line is going to be y minus the y value, right? So y minus 3 equals m, which is 9, x minus 2, right? That's my equation of the tangent line. Now, they didn't specifically say that you have to solve it for y, so that answer should be just fine. But if you wanted to solve it for y, the safest way to solve it for y is to just add the plus 3 to the other side without bothering to distribute the 9. Right, so that's the first thing they asked, is they asked for the equation of the tangent line. The second thing they asked you to do was use the equation of the tangent line. So f of 2.1 is going to be approximately a 9 times, if you plug a 2.1 in here, you're just going to get a 0.1 plus 3, so you're going to get 3.9. So f of 2.1 is approximately a 3.9. Cool. Part C is the part that we shouldn't at all be surprised is coming, because this is a separable differential equation. Part C wants you to separate and solve using that same initial condition that f of 2 is 3. So when I separate, I'm going to multiply the dx over to go to the right-hand side with the other x stuff, and I'm going to divide the y squared over. So I'm going to get a dy over y squared equals a dx on top of an x minus 1, right? The d stuff has to be on the top, all right, when you multiply this stuff across. So this is not a natural log, right? This is a y to the negative second dy. And this will end up being a natural log because it's 1 over x minus 1 dx, right? So you have to separate the variables. If you miss this step on a separable diff EQ, you get nothing. It doesn't matter if you do something completely mathematically brilliant and amazing after this. If you miss this step, you get nothing on this part. So I use the power rule to integrate y to the negative second. I up the power to -1 and divide by -1. So I'm going to rewrite that as a -1 over y. I'm not going to write my plus c because I'm going to put the constant of integration on the side with the x. So this is the natural log of the absolute value of x minus 1 plus a c, right? So they said find the particular solution y equals f of x. So that's code for you have to solve for y. So now I've integrated, right? So I separated my variables, I did the antiderivatives, I made sure to use the constant of integration. The last two things I have to do, and you can do them in either order, I need to find c and I need to solve for y. Now you can either solve for y and leave c as it is until you know, and manipulate it accordingly, and then once you've solved for y, plug in, or you can find c now. It doesn't really matter which one you pick. So I'm just going to go ahead and find c now. So I'm going to use the point 2, 3 to find c, right? So -1 over 3 equals the natural log of 2 minus 1, which is just a 1, plus c. Well, natural log of 1 is a 0, so it seems to me that my c is a -1/3. So I now have c is -1/3. Great. So up here, I'm going to recopy this because I'm going to erase in a second, and I'd like to have my work so that I don't have to start from scratch. So let me actually give myself some space. So what I have now is -1 over y equals the natural log of the absolute value of x minus 1 minus a third, right? That's my answer so far. So the last thing I have to do is, because they said y equals f of x, that means y is some function of x, so you're going to have to solve for x. So, or I'm sorry, you're going to have to solve for y rather. So there's a couple ways to do this. Honestly, the laziest and easiest way to do this is that what I can do is I can treat this whole guy like he's a fraction over 1, right? I can multiply the y. I can either cross multiply, or I can just multiply the y over, so I get -1 equals this whole thing, right? Times y, and then I can divide that guy over. Now, an interesting thing's going to happen here, and we're going to talk about what that interesting thing is in a sec. All right, so this is my answer in terms of y. So if you look at the AP solution guide, they're actually not going to give you an answer that involves an absolute value of x minus 1, because they're going to tell you that there is a restriction here, that this solution is not actually valid for all values of x, right? So this is a right answer, right? But if you look at what the AP guidelines actually have, right, the AP actually, well, now they bother to factor out the negative and then switch the order of these on the bottom, but I'm going to leave it this way. They make it a natural log of a positive, or of just a regular x minus 1, right, minus the 1/3 equals y. So they didn't bother to put the absolute value. Now, what that's implying, right, so what that's saying is that saying that because the natural log of 0 is not a thing, right, there is a domain restriction on this, that x minus 1 would have to be greater than 0, so x is greater than 1, right? There would be a domain restriction there. But if you think back to the slope field we drew, the slope field had like a vertical asymptote. It was undefined. If you think about, so if we look back at the original dy dx, right, it was a y squared over an x minus 1. See how this thing is undefined if x is 1? So essentially what happens is, whichever side of the graph you're on, it's going to yield a particular y value. So how to phrase this accordingly. So you're either on, if this part's undefined, you're either on this side of the graph, like the side where x values are smaller than 1, or you're on the side of the slope field where x values are bigger than 1, but because of this undefined section, you're never going to cross it. So if your point that they're giving you, which in this case is over here, because the point they gave you, sorry, my marker kind of died, the point they gave you was at 2, 3, right? That was the point. Well, if that's on this side, like if this is that weird dead zone, right? You're either on this side of the dead zone or you're on this side. So all this is saying is, oh, hey, because it says 2, 3, I know I'm on that side of the dead zone, right? The other restriction the AP gives you, which is interesting to point out, is the restriction they give you is essentially that this thing has a vertical asymptote, right? So if the denominator, so the AP gives you 2 restrictions, and I don't, as far as I can tell, actually think that you would have to have the restrictions to give credit, but I think when we see restrictions like this on a solutions guideline, we should ask ourselves, why are those there? And at least make sure we can do a check to figure it out. In the end, if you missing a restriction on a domain is the thing that gets you 8 out of 9 points on an AP free response, it's not the end of the world. But it's good to look at a restriction like this and think, hey, logically, why is that there? So the other issue is that this solution, y equals f of x, actually has a vertical asymptote if the natural log of the quantity x minus 1 minus a third is 0. Well, that would be when the natural log of x minus 1 equals 1/3. If you exponentiate, that would be when x minus 1 equals e to the 1/3. That would be at x equals e to the 1/3 plus a 1. So somewhere down here, wherever that is, right, wherever this e to the 1/3 plus a 1 is, right, somewhere there's another vertical asymptote. Well, what that means is that this solution is only valid in the window between those vertical asymptotes. So when the AP says, oh, this only works between 1 and e to the 1/3 plus 1, the reason they're giving that domain restriction is essentially that there are asymptotes at 1 and e to the 1/3 plus 1. Because 2 is a number in between those two values, this is the window where this solution works. If they had given you a point like over here, right? If they'd given you a point over here, then you'd be looking at values on this side of 1, right? So that's sort of the logic why. Again, I don't think that that's going to keep anyone from getting a good score on the AP, but it's worth noting why those domain restrictions exist and why those little notes are there.